Hi everybody, I'm Greg Fishel and welcome to bonus weather video number 2 for this week. And we're going to be talking a little bit about winds and isobars. We've actually got a cold front that is moving into North Carolina right now, and there's considerably cooler air behind it. And I don't know exactly how well you can see some of those really teeny numbers there. But if I highlight some of these, this was at 5 o'clock this afternoon. It was 83 at the Raleigh-Durham airport. And then back here in eastern Kentucky, it was 66. Temperatures were in the 50s back here in Indiana, and even some 40s up here in southern Wisconsin. So quite a bit of temperature contrast behind it. But we're not going to be talking about that today. What I want to point out is what the wind is doing with respect to the isobars, because it's a little bit different than what we talk about in theory. And oh, by the way, an isobar is not a place where meteorologists go to get drinks. I've thought about that as a entrepreneurial endeavor down the road to create an establishment called the Isobar, but haven't quite gotten around to that yet. Don't have the venture capital available to do that. But I wanted to make that clear that isobars are not what that is all about. Okay, so let's go back to our map here. And if you look really carefully, I'm going to see if I can't highlight one of these for you. Okay, so I've drawn in the isobars here. That's what that line is right there. It's a line of equal pressure. And you see these little lines that are coming out of all these stations here. So let's highlight this one right here, okay? That line, and I know I drew the circle. In fact, I'm going to redraw that circle so that we can get a little bit better idea. No, that's still not going to work. All right, Greg, obviously you're not comfortable with the software yet. There we go. All right. So that line coming out of the station is actually blowing from northwest to southeast, but the isobar is oriented from northeast to southwest. And I always talk about the fact that the wind basically blows parallel to the isobars. So you're probably asking yourself, Greg, you've been lying to us all this time? Well, not really, but there's another effect that's coming into play here, and so let's talk about that. So a little review, first of all. Oh, and I need to clear that little circle off of there so it's not distracting. There we go. So you have an area of high pressure, okay, and or area of low pressure and area of high pressure, and of course the winds in the northern hemisphere go counterclockwise around the low and clockwise around the high, and there's a balance of forces that comes into play here. The pressure gradient force is directed toward low pressure, from high pressure to low pressure, so we're going to call that PGF, got to have an acronym. And then the Coriolis force, which is due to the Earth's rotation, actually blows to the right of the flow, and that's all because of the fact that the Earth is rotating. Those two forces balance each other, and so in theory, the wind should blow parallel or along the isobars. Same thing with an area of high pressure, although in this case, the pressure gradient force always is directed toward lower pressures. So that would be off to the right here, and the Coriolis force always to the right of the flow going toward the left. However, because of land and the friction that is associated with land, it turns out that the Coriolis force is proportional to the wind speed. So if friction over land slows down the wind speed, the Coriolis force decreases along with it. So the pressure gradient force then becomes the dominant force in toward low pressure, and with the area of high pressure, again, the pressure gradient force becomes the dominant force. And so as a result, the winds actually blow across the isobars, at least to some degree, toward low pressure. So in the case of a high, the air would sort of spiral out of the high, okay, and with the low, it would spiral into the low. And that's all because of the fact that friction is slowing down the wind, which is slowing down the Coriolis force, which is then allowing the pressure gradient force to become dominant, and the air actually is directed across the isobars, at least to some degree, toward low pressure, into the lows, out of the highs, across the isobars. Okay, does that make sense? I hope so. All right, so that's the bonus weather video for today. We hope you have a wonderful weekend, and we'll be back on Monday with another daily weather update, and another bonus weather video will be on the horizon for next Tuesday. So we hope you'll join us for both of those. In the meantime, take care, be safe, and we'll talk to you soon.